Good afternoon, everyone. My name is Tony Ray. I'm Technical Director and Majority Owner of Steelco Adhesive. We're located in Northeast Philadelphia. The company was originally started by Jim Field in 1976. He purchased a company named McNabb Laboratories. Not McNabb, but it was just a guy's name, and the little company. He moved it to Northeast Philadelphia from Lancaster, Pennsylvania. And he grew a little bit over the years. I came on board in 1993 out of ICI America's Advanced Electronic Materials Group as a one-year position in my mind, since I was in the second year and I was doing research development. And so I want to have a job and find another one back in the ivory tower world. Here I still am. We grew the company as technical director until October of 2004. And my business partner and I acquired the assets of the business in 2004 when Jim Field retired. And we've been growing the company ever since. We specialize in value-added, two-component, one-component thermosetting epoxy adhesives and ultraviolet curable adhesives in a variety of specialized industrial applications. Some of the systems we're in the abrasive grinding wheel area, and flat wheel area, we supply adhesives for abrasive converting. We supply adhesives into aerospace applications for temporary protective coatings and temporary bonding. We supply adhesives into the electronics industry for splicing, dicing, coated with gas systems, and a whole variety of other areas. I've been in chemistry for 34 years now. My background is bachelor's in chemistry, organic chemistry, orthochemical, analytical chemist for a little over 7 years. Went to ICI America's Advanced Electronic Materials Group for about 10 years, doing polymer synthesis work and ultraviolet curable 3D injection molded circuit boards, a whole variety of material-related applications for the electronics industry. And then in the Steelco, coming up to speed on all the epoxy chemistry, as well as other chemistries as well, polyurethane, silicone-based material, that type of thing. Sean came to us approximately 2 years ago, looking for a alternate source for a protective, reflective, full component roof coating. He was looking for someone out of the industry base who produced material for that industry. We had really never gone after the construction industry. We didn't see it as a technology fit, an innovation fit, or it's not within our business model. Our business model is to go in, take applications, find out a customer-specific need, and develop a unique product that solves very specific market-driven needs within that application base that is not being addressed by other suppliers in the industry, and then we're constantly evolving those products organically within my own organization. We're keeping all the technology fresh, bringing options to our customers before they even come to us wanting something different. It helps us, but we're constantly to know in the end application and what the customer's needs are now, what their future needs are going to be. So when they come to us, we're not scurrying around to develop something. We already have the answers off the shelf for them. So when we started looking at the epoxy system that was brought to us, we started looking at other technology bases that were available that we thought were applicable for the application. Mainly, we try to be as green as possible in all of our applications. Safety at our company is number one. We have a injury rate, lost time rate. A little bit about the size of the company on this. Last year we did about 2.3 million pounds of epoxy adhesive. We put it out for a facility, 14 employees, and extremely high quality oriented. We have a very sensitive quality system on incoming raw material, back-to-back consistency, as well as orders going out being correct. So with that said, when we went and again began to dissect the roof coating, we saw some improvements that we thought may be applicable. First off is safety and environmental concerns. With the volatile organic compounds that are in our formulation, nothing like this solvent in the world we're dealing with, so from an operator safety perspective, as well as an environmental safety perspective. So we started looking at ways of getting away from that within a full component system, and then we began to investigate looking at the moisture cure system that we have experience with in other applications. We sought to bring a user-friendly, high-performance, reflective coating into the roofing industry base, looking at, again, the environmental improvements, safety improvements, and also end-user friendly system. I know from the full component world, you're mixing the two-part epoxy together, and a pump goes down, the mix ratio isn't right. Even in a highly technical environment, it's not properly maintained. It causes performance problems and product failure. In the construction industry, this is only going to be exacerbated by the need of getting the job done, the people that are applying the coating not being material people. So if they're a couple pounds short on a beam, it'll be okay, we'll mix up half of what we need, it'll be fine, and 2 years later you have a corner of a roof blowing off. So bringing a one component system, we thought brought a great deal of value into the system. The components of the material is a fairly new formulation in terms of the combining of the material. But I'm going to break out the basic components of the formulation and give a little history on those basic elements. The polymer binder, the organic system that reacts with moisture and creates an elastomeric, permanent binder final coating of the system is based on some aliphatic chemistry that has been around since about 1963 when they first started coming out. These aliphatic moisture systems are extremely weather resistant, ozone resistant, resistant to yellowing from ultraviolet light exposure, chemical resistant, extremely flexible, good impact resistance, very good tear resistance. They are elastomeric, so they can expand to a certain point and then come right back to their original position just like they lump in. Those expansions and contractions take place. The materials are highly ductile. There's no flex fatigue failure over time with these types of systems. And they're very resilient and application proven from the chemistry perspective. They've been used in exterior concrete coatings, sewage treatment plant coatings, wastewater containment, reservoir lining, pipe lining, effluent tanks from wastewater purification, from the exterior coating perspective. They're also used in furniture coatings, architectural finishes, OEM, architectural coatings, protective top coatings, the top coatings on for cars and trucks. They're used in automotive repair coatings, and also elastomeric waterproof inner layers for parking decks, bridges, and marine decks. So the basic chemistry, the organic chemistry that's being used in the system is extremely proven in multitude of high-performance exterior applications. The primary pigment in the system is titanium dioxide. It gives it the UV and light reflectivity that's needed to have the coating not get hot when it's exposed to sunlight to UV, and also the emittivity to dissipate any thermal energy that is translated from UV light that is absorbed. We use materials from DuPont. They've been in the business of mining, purifying various grades of titanium dioxide for 71 years, and a whole variety of end applications, and really fine-tuning the various grades for the specific needs of paint and outdoor coating. The other fillers that are in there are used extensively in the electronics industry. There's certain filler in there that helps to retain the combustibility of the material when it gets to a specific temperature. Several moles of water is evolved from those inorganic materials that help to keep the fire suppression level down. We incorporate Kevlar into the system, as you all know. Kevlar has been coming along for years as a clothing for firefighters, ballistic prevention, bulletproof vests, high-performance composite structures, and they've also come up with various grades that we're now able to use in the coating and adhesive rounds, which we're incorporating into the final collaborative system. These are deflocculated Kevlar filaments that are homogeneously dispersed into the coating. They increase the surface wear of the coating. They increase mechanical properties and tear resistance to the coating by anthropopically reinforcing the system. And they also add some very unique flow properties to the coating and improving sag and those type of properties, which is be able to put it on a vertical surface, on rougher surfaces, and not have it drip, splatter, and poop all over the place. As far as adhesion goes, the fact that it's a moisture-reactive material, any surface that it goes on that has what we call hydroxyl functionality, half of the water molecule, H2O, well, if the OH is present anywhere on the surface, and those OH are present on metal surfaces, they're present within the structure of wood, within the cellular structure of wood, on various plastics, the coating will chemically bond with that functionality and create a chemical covalent bond, bonding it permanently to that surface. In addition, with the structure of the backbone material, it also bonds through hydrogen bonding mechanisms, which on a molecular level are very strong and help to really hold things together. The solvent that's in the system is VOC exempt by the EPA, and it's a safety solvent. That's why we incorporated it into the system. We're currently looking at removing that solvent system. We're having an ongoing R&D effort again in all of our projects. So looking even at the new best coating air, from what Sean says, for the roofing industry, let's try to get that no solvent. So we're working now on removing that solvent, having a 100% solid system, so everything that's in the bucket goes on the roof, stays on the roof. So there's no yield loss from solvent evaporation, there's no flammability, those types of things. We're looking at further improving the reflectivity by some novel silver-coated polyglass spheres that are out for other applications. We're investigating various ways to tin it, and also taking feedback from Sean and his leads on other applications outside of the roof coating area to see where we need to further redirect the product and other formulations. So we're constantly on top of the technology that's out there. We're constantly looking to improve the product, and we're constantly serving our customers with a high-quality product, consistent product from back to back. Every order that leaves my facility is correct, and all of our employees are trained in a high level of quality, and I still on them every day that we win the business one order at a time. Developing the product, closing the sale is the easy part. Keeping the account for over 20 years on a 5th generation product,